So in this video, we're going to be looking at using sine to calculate the length of an unknown side or to find it. So if you're wondering what exactly sine is, it's basically the trigonometric function, which is equal to the ratio of the opposite side to the hypotenuse. So I'm just going to highlight that because I think that is quite important that you note that it is equal to the ratio of the opposite side to the hypotenuse. Remember that the opposite side is opposite to a given reference angle, and always remember that the hypotenuse is opposite to the right angle. So if we take a look at the diagram of the right angle that I have here, so I have labeled the sides of this right angle triangle. Just a couple of things I haven't though. The angle which is represented by theta, that's also known as our reference angle. And looking at this little square, we know that is what's telling us that this is a right angle triangle. So in my last point, I said, remember that the hypotenuse is opposite to the right angle. So if we take a look at where the right angle actually is and where the hypotenuse is, you can see that they are opposite to each other. We also know from our work with Pythagoras, the hypotenuse is the longest side of the right angle triangle. Moving up the points that I've given you here, I've also said that the opposite side is opposite to the given reference angle. So if we take a look at where the reference angle is and where the opposite side is, you can see that they are also opposite to each other. So when you are labeling your right angle triangle, it's always a good idea to have a look at where the angles are and from there work your way around, and especially when you're labeling your opposite and your adjacent, because it is very easy to get them too confused. So when we are looking at using sine, there is an acronym called, or there is a sort of a way to remember, which is SOHCAHTOA. So when we're looking at using sine, which is represented by SO, you can see here that we've got sine, so that's the S, and then you can see the OH. So what that's telling us is that for this particular ratio, we need the opposite to be divided by the hypotenuse. So if we take a look at the key equation that I've given you here, I've said sine of the reference angle, or theta in this case, is equal to the opposite divided by the hypotenuse. So keeping this in mind, let's go and have a look at two worked examples that we'll be working through together. If you want to give it a shot, feel free to pause the video now, try it out and see whether your answers do match the ones in this video. Just a couple of things here. For the purpose of this video, I am using the scientific calculator that is prescribed by the school, just because then you can familiarize yourself with the process and the little hints and tips that I do give you along the way. If you have any other scientific calculator, this will work exactly the same. Your calculator buttons and functions might just be in a different area, that's all. So if we take a look at the first example, I would highly recommend starting by actually labeling your sides. So first up, we know the length that's represented by the number 16 is our hypotenuse, so I'm just going to write H for hypotenuse. Our reference angle here is 23 degrees. And then we've got the side M. So that's obviously going to be our opposite. And we know that it's opposite because it is opposite to the reference angle. So if I try to put all this information now into our key equation, what I will end up with is writing sine of 23 degrees is equal to M divided by 16. Now, if you are using a scientific calculator, there is one more step we will need to do in order for us to be able to actually calculate what the length, which is represented by the letter M in this case, is. So we need to move that 16 over to the left-hand side, and the way we do that is by multiplying both sides by 16. So then we get 16 times sine of 23 is equal to M. So now if we take a look at the scientific calculator, so what you need to do is make sure that your calculator is in degrees mode. So if you take a look at where my cursor is, that's telling us right now my calculator is in degrees. If that little d is an R, that's telling you your calculator is in the radians mode. So you'll just need to press shift, set up. Sorry, I didn't press shift. You need to press shift, set up, and you can see here that we've got 8 different options, you need to select option number 3. That will make sure that your calculator is in degrees mode. So now all you need to do is just type in 16 times sine of 23 degrees. So I'm going to write 16 times sine, and that'll open up a bracket. So you just need to do 23 or write in whatever reference angle it is. Make sure you close the bracket as well, and then press enter. And what we've been told here is that this answer is equal to 6.251698,056. Now, I haven't actually explicitly written it down, but let's assume for this activity, we're rounding to the nearest 2 decimal places. So here I'm going to write m is equal to 6.25. So what that tells us now is, in relation to this particular right angle triangle, m is equal to 6.25. Now, I said we talked about the hypotenuse in Pythagoras' theorem, so we know that the hypotenuse must be the longest side to this particular right angle triangle. The fact that we've worked out m is 6.25 suggests that we are potentially correct. We know we are because we've used the calculator and we've inputted our information incorrectly. But if you were to get m to be any number bigger than 16, chances are you've made a mistake somewhere, because remember, the hypotenuse is always the longest side of this right angle triangle. So looking at the next example, I would definitely recommend starting by labeling our sides so that we can easily start to use the equation based on the information we've been given. So if we take a look at the second example, so we can see that my reference angle, which this time I'm just going to write RA, is 27 degrees. Looking at where the reference angle is and looking at the side that's been given the length 5, we know that 5 is actually our opposite, being that it is opposite to the reference angle. Then we've got P, which happens to be our hypotenuse because it is opposite to the right angle. So here, if we look at the information that we have and what we're being asked, we know that we're being asked to find the hypotenuse this time. So if I write all my information into the equation, so we know sine 27 degrees is equal to 5 divided by P, because P is the variable that this time is representing our hypotenuse. So now with this particular calculation, we are going to have to do one more step in comparison to the first question in order for us to be able to put this into our calculator. Now, if you are using a graphics calculator or a CAS calculator, you are able to use solve as a function, but like I said, for the purpose of this exercise, we are using the scientific calculator, so we do need to prepare this, our working out just a little bit more in order for us to use the calculator. So if I take, if I move P to the left-hand side, I'm going to multiply both sides by P. So I've got P times sine of 27 degrees is equal to 5. Now you can see here that we're still in a little conundrum where we can't actually type P times sine 27 equals 5 into our calculator. So we do need to move sine of 27 degrees, to the right hand side. So I'm going to divide both sides by sine 27. So then I've got P is equal to 5 divided by sine 27 degrees. So now we can put this into our calculator. So all you need to do is use the fraction function on your calculator. So type 5 up the top for your numerator. And for our denominator, we're going to write sine 27 degrees. And again, just make sure that your calculator is in degrees mode. And I'm going to hit enter. So what I've got is P is equal to 11.01. So what that's telling us now is that our hypotenuse has a length of 11.01 units. So hopefully by the end of this now, you're feeling a little bit more comfortable in terms of what sine is and how it could be used to find the length of an unknown side. Remember, practice does make perfect. So I would highly recommend doing the assigned tasks now, because now that you have the background knowledge and understanding of sine, you'll be able to consolidate it through the tasks that I've assigned for you. my biggest hint here, or my biggest strategy in terms of using any trigonometric function, sine, cos, or tan, is to definitely label the sides of your right angle triangle. Once you label everything in there, it becomes so much easier to use the equation, or know which equation to use, because you've identified each and every key aspect of the triangle that you've been provided.